Now let's take a look at our third example. Given a network address and a subnet mask, provide the valid subnet numbers or subnet addresses. Here, we'll learn a shortcut called the magic number. Okay. Here, we're given a network address, 172.16.0.0, and we're given a subnet mask, 255.255.224.0. In this situation here, what we're doing is we're using decimal here, and of course we're breaking these out into binary. And we want to learn a little rule called the magic number. What we're trying to do is come up with the valid subnet addresses that we could have here. So once we've got this subnet mask here, we could actually draw a line from top to bottom. Draw a line there from top to bottom. And now here's the network section, here's the subnet section right there, and then we've left over the host section over here. In that subnet section, this is where we're going to be able to manipulate bits to be able to figure out what our different valid subnet numbers would be. The first valid value that you could plug in here would be all zeros, 3 zeros. The next valid value, counting binary, would be 001, and then 010, then 011, 100, 101, 110, and then 111. Here's where we get the 2 to the nth minus 2. This first value right here, if we go back to our list of tasks, those rules that I gave you, the value for subnet, since we're trying to come up with subnet numbers, if you use the subnet number rule, it would say to set all the host bits to 0. If we set all these host bits to 0 here, and we'll just set all those to 0, this number 172.16.0.0, problem is with that one, that's the same as the network address. See, the network address was 172.16.0.0, so we cannot use this as a subnet number. Now, actually, in further courses, you'll discover some other ways of getting around that particular rule, but that's a rule that we're going to follow at this point. So that's 2 to the nth minus 1. That's where the minus 1 comes from. And then we come down here and we'll find the minus 2. One of the other rules that I showed you was about the broadcast address. We said the broadcast address was where you'd set all the host bits to 1. So if you set all the host bits to 1 here, then you would end up with 172.16.255.255, which happens to be the same address as the broadcast for the major network here once again. So therefore, we cannot use this as a subnet because its broadcast address would be set for everybody. So that's our 2 to the nth minus 1, 2 to the nth minus 2. Those are the two that we cannot use. So here is where we come up with the remaining valid subnets here. We've got 1, 2, 3, 4, 5, 6 valid subnets that we can use. Let's take a look at what this first subnet number is. Remember, the subnet address rule is set all host bits to 0. So we set all these host bits to 0. And this first subnet is 172.16.32. Take this number, and that's the number 32.0. So 172.16.32.0. The next subnet is 172.16.64.0. Set all the host bits to 0 there, and you get 64. And then you've got 172.16 and then 96.0. And this would continue to increment until you got all those different subnets. Now, instead of going that long approach through all of the bits there, let's look at a real quick shortcut that we could use here called the magic number. The magic number is 3 things. First of all, it is the value above the last bit in the mask. Look at the value above the last bit in this mask. Here's the mask. There's the last bit right there. It's 32. So that is the magic number. Second thing that the magic number is, it is the first subnet. So notice, as we said before, we had the first subnet as 172.16.32. So that was the first subnet. So the magic number is that value above the last bit. It is also the first subnet. The third thing that the magic number is the increment. So we'll take the first subnet, 32, plus 32, and we get the second subnet, which is 64. Add 32 to that, and we get 96. And that is the number by which all of the subnet addresses will increment. So the magic number is three things: the value above the last bit, the first subnet, and the increment.